Welcome, everyone, and thanks for coming. This is a huge room. There is a lot of people, and I'm very happy and excited about that. Today, we're going to see together what order of operations means in Tableau. So when we apply some filters, when we apply some operations in Tableau, they will be applied in a specific order that we're going to learn together today. My name is Silvia Cioffi, and I'm a senior product consultant based in the London office. And today, I will be your own guide into the wonderful world of Tableau order of operations. This is an intermediate session, so I expect from you just to have a basic knowledge about the Tableau interface and also some knowledge about basic calculations. But around Tableau order of operations, we're going to see together how to use it step by step. We're going to go through some a little bit more trickier examples. And if you miss some steps, really no worries about that. This session has been recorded, so you can watch it after as well. And the important thing for you today is really to understand the logic that there is behind Tableau order of operations. So when you go back to your offices on Monday, you can leverage it in order to build your own visualizations. I'm going to start today with an exercise for all of us. And now we're going to go back to school, and I'm going to give you a few seconds to solve the calculation that you see at the top of the screen. So raise your hand if you think that the correct answer is A. Any B? Can see a big majority. C? And I'm not going to ask for D because Tableau Data Night Out is tonight, so I expect still all of you to be awake after devs on stage. And the correct answer for this calculation was B, and I'm going to go back to this in a minute. After this, I'm going to jump into a very different example. And if my accent didn't give it away already, I'm originally from Italy. And as you can imagine, for us Italians, cooking a good and delicious dish of pasta is very, very important. So I thought this was a very good occasion for me to come to Las Vegas and tell you what's the perfect and very simple recipe to cook a dish of pasta. So let's see together how to do it. We first need to boil the water and then add pasta and salt. Let's wait, I will say 10 minutes, 15 is a bit too much. And then we can prepare our delicious dish of pasta, carbonara, amatriciana, the one that you prefer. But I'm sure now you're thinking, I actually came for a Tableau presentation about order of operations. So why Silvia first started with a math example, and then she moved to a cooking example? So let's go back to the previous slide. In order to answer with the correct answer to this example, we need to follow a specific order of operations that is the one that you see on the right-hand part of the screen. Let's do it together. So we first need to apply multiplication and division. So 4 times 5 is 20, and 10 divided by 2 is 5. And after solving these two first parts, then we can apply addition and subtraction. So 20 plus 5, 25, minus 3, 22. And that's the only way to get to the correct result. In the exact same way, in order to cook a delicious dish of pasta, we need to follow these steps. And I know some people, especially outside of Italy, they think that putting pasta in cold water is the same. But for us, it's absolutely not the same. So please don't do this, especially with us. Otherwise, this is the reaction that you will receive from Italians. But now we have seen how order of operations is important for calculations and for cooking. But let's see now why order of operations is important in Tableau. So why you should pay attention to me for the next hour. And to do that, I'm going to jump into the best tool ever. So for this specific example, I'm going to use the sample superstore dataset This is the dataset that comes with every Tableau release. It's a transactional dataset where every row corresponds to a transaction that happened in my superstore. And I'm going to start by dragging sales to my columns so I can see the total sales. And let's see this information at the order level. So I'm going to drag order ID into rows. We have a lot of orders, of course. Let's sort it. And because I work mainly for the Italian market, now I'm interested in seeing what happens just in Italy. So I'm going to drag country into filters, and I'm going to select Italy. And still, I have a lot of orders. But I really want to focus only on the first 10. So let's see what happens when I apply a top 10 on my order IDs. So if I go here, I just dragged my order IDs into the filter pane. And from here, I'm going to select the top 10 orders by sum of sales. When I apply this filter, as you can see, everything disappeared. What happened? Let's go back here. So this is the reason why order of operations is important in Tableau. We can get to some very unexpected results, and we're going to see together how knowing the order of operation is going to help us. Let's see what we have for today. We're going to start by seeing different types of filters and operations that we can apply in Tableau. And I'm going to do a quick demo of the most important filters, the ones that you see here. After that, we're going to see how these filters and these operations are going to fit inside the Tableau order of operation. And we're going to have some fun mixing more filters and more operations together in some common scenarios. And we're going to see how these filters and operations are going to behave together. And at the end, I'm going to leave you with some main takeaways. So by the end of the session, I really want you to know how to use the Tableau order of operation in order to build your own visualizations. In particular, how to choose the right set of filters and operations to achieve what you want to achieve, to build the visualization that you wanted to build. And third, you are going to know how to troubleshoot unexpected results as the one that we saw before. So we're going to see together how to fix that. Let's start by having a look at the Tableau order of operation. So the order of operation is the one that you see here in the slide. And I know it's a lot of information right now, so really I don't want you to memorize anything of that, but I want to have a look at it, and let's break it down together. So another thing important, if I refer to it as Tableau order of operation or query pipeline, I'm referring exactly to the same thing. So we can call it in both ways in Tableau. We are still referring to these. So let's start by focusing on the left-hand part of the query pipeline. So here we can see a list of filters. And the order in which we see these filters is the exact order in which these filters are going to be applied inside Tableau. So the one at the top, that is the extract filter, is going to be the first one to be applied. And in the exact same way, the one at the bottom, that is the table calculation filter, will be the last one to be applied. So table calculation filter is going to be dependent on what we have in the view. Let's move to the right-hand part of our query pipeline, and let's have a look at parallel operations. So in the same way, the ones at the top, so for example, sets, top n, fixed LOD, they are going to be applied between context filter and dimension filter. And the one at the bottom, like trend lines, reference line, they will be applied last. So they will be dependent on anything else that we have already in our view. OK, so now we are ready to start. And let's start with the first two filters that we have in our query pipeline. As you can see, these two filters are related to the data source. The first one is called extract filter, And the second one is the data source filter. Before going into more details, I really want everyone here to be on the same page. So I'm going to give you a quick explanation of what extract means in Tableau. So when we are in Tableau Desktop and we connect to a data source, like for example, here I connected to my Superstore dataset, I can decide if I want to connect with a live connection or with an extract. If I decide to have a live connection, it means that when I build my visualization, all the queries that are built behind the scenes by Tableau will be sent directly to the data source. If I decide to build an extract, I'm bringing data in memory. So I'm doing a snapshot of my data set, and I'm creating this table with the Tableau data engine called Hyper. So let's go back to our filters. Right now, we're going to focus on the extract filter. So as the word says, this filter can be applied only on extracts, and we can use them to filter out some data. So for example, if I'm connecting to my Superstore dataset, and I have data related to the last 10 years, but I really need just the last 2 years, and I'm creating an extract, I can just cut out all the 8 years that I don't need. So my extract will be lighter and faster to be created. The only thing that we need to remember is that, as I said, we are cutting out some data. So once I create my extract, I can't go back to have the 8 years that I cut away. So if I want to have those data, I need to recreate that extract. Let's see now how to use the data source filter and how it is different from the first one. Data source filter can be applied to both extract and live connection. In this case, we are not cutting out any data. And a very common use case is to use them when we want to publish this data source, and when we want the final users not to be able to change this filter. So when I connect, for example, to my Superstore dataset, and then I publish this connection to my sharing platform, Tableau Online or Tableau Server, and I want to apply a filter that the final user won't be able either to see or to change, data source filter will be your choice. And a very common use case is for row-level security using user filters. But enough with talking with slides. Now let's go back to Tableau Desktop. I'm going to introduce the dataset that we're going to use today that is called Pantheon. This Pantheon dataset is coming from the Pantheon project developed by the MIT. And in this dataset, we have a list of historical figures that have a biography in Wikipedia. And these historical figures can really go from Julius Caesar to Michael Jordan. We have everyone that has a biography in Wikipedia. And we have some very useful and very interesting metrics, like, for example, the historical popularity index that we're going to analyze, but also page views. So how much people are searching for these for these historical figures inside Wikipedia. And let's start by playing with these. And let's focus on the art domain. And let's focus on the actor occupation. So I'm going to ask you, so this scatter tree map that we see here at the bottom is hiding historical figures sorted by the most viewed to the least viewed in Wikipedia. So any guess on who's the most viewed actor inside Wikipedia? Just shout out some names, and we're going to see together if it is right or not. I can't hear. Sorry? Brad Pitt. OK, it's a very good guess. But actually, we're going to be very surprised by the answer, because the most searched person, exactly, I had exactly the same reaction, is Miley Cyrus. So my first reaction was, is she an actress? So I went on Wikipedia to check, and And yes, among the different things that she does, she also is an actress, and I can see that she's also a very popular one. So OK, we had the first run with our very interesting data set that we're going to use today. And right now, let's see together how to apply a data source filter. So I'm going to move to my map. And because we are in Vegas today, let's focus only on searches that are coming from the US. So when I want to apply a data source filter, I'm going to show you two ways in which you can apply it. The first one is directly from your worksheet. If you navigate to the top left corner, then you right-click, and you can edit data source filter. So you can apply them from here. And when I click, I can go ahead and choose my filter. But I'm going to also show you how to do it directly from the data source pane, because I think this is going to stick more into your mind, because it is related to the data source. So if we go here on the top right corner, we have this option to add a filter. Again, it's going to be the same. In both cases, we are applying a filter at the data source level. So let's go ahead and add a filter at the country level. And let's select United States. OK. When I go back to my visualization, I can see that now I have only the United States. And this filter, of course, because it is applied at the data source level, will be applied to all the visualizations related, connected to that data source. So another guess for you. So without choosing any domain or any occupation, who do you think is the most searched person from the US? Sorry, I can't hear. Donald Trump. Yeah, it's a good guess, this one as well. But again, we will be very surprised because it's Kim Kardashian. Yeah, I was expecting also a politician like Trump or Obama, but no, Kim Kardashian. And this is a very nice dashboard that my colleague Ariane built. So if you want to have fun with it, you can find it on Tableau Public. OK, so let's continue our journey inside the query pipeline. We have seen how to use and what are the differences between the extract filter and the data source filter. As you can see, I grayed out a filter that is called context filter, because this is a bit trickier. So I think we're going to understand it better covering first the other three. So we're going to go back to the context filter later. Right now, let's see an example of a dimension filter followed by measure filter and table calc. So what we need to remember is that when we build a visualization, the dimension filter is the first one to be applied, followed by the measure, and last one, as I said, is the table calc. So the table calcs are always going to be dependent on the visualization. And because the dimension filter is too easy, I'm sure if you use Tableau, you know better than me how to use it. I'm going to add a bit of complexity, and I'm going to show you how to use a conditional dimension filter. So let's go back to our interesting data set. And right now, we are visualizing different industries. And each circle is telling us, for this specific industry, how the historical popularity index is doing against the average views. So if, for example, we focus on this corner over here, we can see that history, religion, philosophy, they have a very high historical popularity index, and we can understand why, but they're not very searched on Wikipedia. The most searched industries are media personality and film and theater, as we saw already. So right now, as the title says, I want to filter historical figures with the low historical popularity index. So I want to stick only to my historical figures that have a high historical popularity index. So let's start by dragging into the filter pane our historical figures. So historical figures is not a dimension that I have right now in my visualization, but I can drag it here into my filters pane. And this is how a dimension filter looks like. So if I want to apply it in a manual way, let's say. If I know already which are the figures that I want to filter to, I can just select it from the filter, from the list, sorry. But if I want to apply condition on top of it, I can just navigate here to the condition pane. And from here, we are going to filter historical figures with historical popularity index in average that is, let's say, bigger than 25. So if I zoom back, I can see that, for example, here we have, let me move this, individual sport that has an average historical popularity index of 18. But right now, I'm going to filter historical figures, so people that have this measure that is less than 25. So I'm going to keep just the one that have this value greater than 25. And when I do that, as you can see, the numbers are changing. So individual sports moved from 18 to 26. And the reason why is that I'm filtering out these historical figures that I have in my data set. And that's why the average score now is always greater than 26, because we filter out all those ones that have less than 25. Let's move now to a demo of a measure filter. And let's continue using our dashboard. And right now, we're going to focus on which are the occupations that are most searched in our data set. So if I filter down to the US, we have seen it before, actor is one of the main ones that are searched in Wikipedia, followed by singer and musician. But at this point, I was really curious to see what is the result in Italy. Let's see if it is different or not. So if I move to Italy, I can see that the results are quite different. And the most searched occupation is politician, and I can see that we don't have a very stable political situation right now, so maybe people go there and look for their politician's biography. Second place, we have soccer player, and again, yeah, soccer is the national sport in Italy, but I was really not expecting religious figure to be there, so I was very curious to go and see which one was the most searched character. And I found that was St. Valentine. And yeah, I could understand why it's not really related to religion, of course, in our country. So right now, I'm going to focus on the bar chart that I created. And we now need to apply this task that we see in the caption. So I want to filter this view to only look at occupations with more than 35 million page views. So what do I need to do? Just to drag page views that I have here in my measure pane into the filter pane. And when I do it, I have a list of options. So I can decide either to apply this filter at the row level if I select the option all values, or I can apply this filter in an aggregated way if I select, for example, sum, average, median, etc. And I'm going to start with the second one because I think it's easier to understand. So when I select sum, what is going to happen is the Tableau is going to aggregate first these page views at the level that I have in the visualization, that is at the occupation level. So basically, first it's going to compute the numbers as we see it in the visualization, and then it's going to filter down the ones that are less than 35 million. Let's see it together in action. So if I click on next, the first thing that I can notice is that this number is exactly this number. So again, Tableau first is aggregating, and then it is going to filter down. And I'm going to type down 35 million. So this is a very good tip. If you need to type million, you can just put a bigger M, and it is going to work anyway. So when I apply this filter, if I have a look at my bar chart here, I will expect all the results after mathematicians to go away. And when I apply, this is exactly what happens. So when I apply a measure filter in an aggregated way, Tableau is first aggregating at the level that I have in my visualization, in this case at the occupation level. And then it is filtering out the results that are less than the limit that I put. Let's see what happens when we apply the same filter, but we are going to apply it at the row level. So this time, I'm going to choose all values. When I choose this, the first thing that I notice is that right now this number is different from this number. And the reason why is that right now I'm filtering out at the row level. And when I apply it, oops, I need first to put the limit here, 35 million. When I apply it, I can see that the result is very different from what we had before. If we look, for example, at Inventor, I can see 89 million. And if I go back, Inventor had 97 million. So also the sum of page views, so the metric that I have here is changing. And why is this happening? If I go to my data structure, this is the data structure of my data set. And this is a very important information that we need to know before starting building any visualization. I need to know what's the row level in my data set. And in this case, the row level corresponds to our different characters. And when I filter at the row level, I'm going to filter down all these ones, for example, that are below 35 million, and I'm going to keep just the ones that are above 35 million. And after applying this operation, then the sum of page views is going to be applied only on the ones that are left. And that's why the final result is different. So right now, we are seeing which are the occupations that are most searched in Italy. And just for the sake of curiosity, I'm going to drag full name here. And let's add all members. Let's make it big. And yeah, I can see very famous people from the Italian history, like Leonardo da Vinci, Galileo Galilei, and others. Let's jump now into the third and last filters that we saw before, that is the table calculation filter. As I said, what we need to remember about this is that this is going to be applied last in my query pipeline. So if I go back to my bar chart, right now, what we need to do, what I have in my caption, is that I want to filter this view to only look at occupations with rank up to 10. How can I compute a rank in Tableau? I can use a table calculation. And what I'm going to do is just to click on my metric here. And if I click on Control and then I drag this, I'm going to duplicate exactly the same measure. So if you know this trick, this is another good one. So right now, I'm just duplicating the same measure. And from here, I'm going to right-click and apply a quick table calculation. And as you can see here, I have the rank option. When I apply the rank, the format number here is not the best, so let's change it. We can see if it is correct or not. OK, so I can see here that I have the correct ranking for all the different occupations. And if I want to look at the ones that have rank up to 10, I can just take the rank that I just computed, and I'm going to drag this into the filters pane. And this is going to be applied exactly as the other filters that we saw. And the thing that we need to remember is that this will be computed last. So now we have seen all the filters, and we have all the basics now and all the knowledge that we need in order to understand how to use the context filter. The main things that we need to remember about this filter is that the context filter is an independent filter. And why we call it like that? So if we have a look at the query pipeline, we can see that the context filter is applied just after the two data source filters. That means it's the first filter to be applied in our visualization. So it comes before the dimension filter, the measure, but even operations like sets, top n, and fixed LOD. So it's the very first filter that is going to be applied in our visualization. We need to remember that it can only work on dimensions, so we can't apply a context filter to a measure. In some cases, it might be used to improve performances. Because, for example, if you have a lot of filters applied in your visualizations, you can kind of prioritize some of them, putting them into context. And last, we can use it to include it just the data of interest. And we can use it if we want to have something that is going to be applied, a filter that is going to be applied before my top n, or my fixed LOD, or my sets. But I think it's going to be much clearer if we see it in an example. So right now, we are seeing different historical figures that are sorted by historical popularity index. And we can see that the person at the top is Alexandre Dumas, that is a famous French writer. And what we need to compute, what we need to find right now is who are the top 10 most popular musicians in Wikipedia. And let's try to solve this together. So the first thing that we need to do is to filter these list of people just looking at musicians. So I'm going to drag industry into my filters, and I'm going to select music. OK, now we can see only musicians. A lot of them are classical musicians that I really like. And now we need to focus only on the top 10 that are most popular. So I'm going to drag my full name into the filters, and I'm going to apply a top filter focusing on the top 10 by sum of historical popularity index. So I want to look just at the ones that are most popular. And when I apply it, again, very similar example to the first one that we saw, we have an unexpected result. I can see only Sting right now, but I'm sure we have a lot more musicians. So why that happened, and how can we solve it? So let's have a look right now at the query pipeline. So this is a very good advice for when things like that happen to your own visualizations. If you have your query pipeline just next to you, then you can do an exercise similar to this one. So let's see what's the first filter applied inside the query pipeline. That is my top 10. So first, I'm filtering down to the top 10 historical figures by historical popularity index. So if I now eliminate this second filter, this is the situation in Tableau after step 1, at step 1, sorry. At step 1, I have just 10 results that are the top 10 figures overall. And after that, I'm applying a filter on music that is a dimension filter. But this filter is going to be applied only on those 10 results. And that's why I'm ending up with one result, because only Sting made it to the top 10 of historical figures overall. And how can we solve this? We need something that is independent from what there is in the view. So we can go ahead and try to use a context filter. How can we use a context filter? If you go to the filters pane and you right-click on your dimension filter that you want to move up to context, you just add this filter to context. And when I'm going to do this, you can see right now that I have my top 10 result list. And we can see a lot of classical musicians, but also some modern ones like Elvis Presley and Jimi Hendrix. So this is how we solved our issue. And if now I go back to my first example, what do I need to do? Add country into context. And if I add country into context, again, I'm going to get with my top 10 orders per Italy. OK, so let's have a look to recap. Let's see what we've done. Right now, the first filter to be applied is the context filter that is narrowing down to the data of interest that are we're only looking at musicians right now. And just after that, we are focusing on the top 10. So first, we are filtering to all the musicians, and then now we're able to see which are the top 10. Let's add a little bit more of complexity, and starting from the visualization that we just built, let's try to add a measure filter on top of it. So right now, we need to compute who are the top 10 most popular musicians with page views over 30 million. So the first bit is the one that we just computed and the one that we have here in the visualization. We have the top 10 most popular musicians. But right now, we want to also look at the ones that are actually searched for in Wikipedia. So let's start by dragging page views, that is my metric, into the filters pane. And right now, it's going to be the same if I select all values or sum, because if you remember, the historical figure is the row level in my data set. So if I aggregate or not, it's going to be the same. So let's go with all values. And again, we are going to filter, as we saw before in the measure filter, just for the ones that have at least 30 million page views. And when I apply this filter, again, I'm ending up not with 10 results, but just with 4. And I'm sure we have way more than 10. How can we check what's going on? Let's do an exercise similar to the one that we did before. Let's have a look at the query pipeline. So the first filter that has been applied is the context filter. We are narrowing down just to musicians. And after that, we are computing our top 10, the top 10 most popular. And I think, again, the problem is here, because the result at step 2 is going to be, so if I remove the third filter, is going to be just 10 results. So only on this list that contains 10 results, we are applying the last filter on page views. And we're ending up just with 4 results, because out of those 10, again, only 4 have page views greater than 30 million. But there has to be a way to compute the right result. So how can we do it? Let's have a look again at the query pipeline. Context filter is fine to be there because we are narrowing down to musicians, and that's correct. Measure filter, we can't do a lot with that. If we need to apply a measure filter, that's the only way to apply it. So let's look for another way to apply a top n. Instead of applying this top n that is happening very high in our query pipeline, do you remember which one was the filter to be applied last and something that we can use? We have it right there. So we're going to try to use, instead of a top n, we are going to try to use a table calc that is going to be applied after my measure filter. So let's go back to our visualization. And we said the problem is with the top n filter that we applied on the historical figure. And I'm going to delete this. So I can see that actually I have a lot more than 4 people with page views over 30 million. And right now, I'm going to apply a rank as we did before. So I'm going to duplicate my measure, right-click, quick table calculation, and rank. And if I make it a bit bigger, OK. It's not showing. Wanted to show to you. OK, it's not showing for some reason. But yeah, we can, this is, yeah, we have it in the tooltip. So we can see this is rank number 1, number 2, 3, and so on. So right now, we can drag this into my filters pane, and we can filter down just to the first 10. And this is how we get to the right result. Let's recap what we have done, going to our query pipeline. So again, the first filter to be applied is the context filter, narrowing down only to musicians. The second filter is the measure filter that is narrowing down just to musicians with page views over 30 million. That means very popular musicians. And after that, we want to see just the one with rank up to 10. So right now, if I have a look at my query pipeline, what about if I move my context filter again down to be a dimension filter? Do you think anything is going to change? It shouldn't. So let's check it together. So if I go now to my visualization, I right-click, and from here, I'm going to remove this filter from context. Everything will stay the same. And this is the proof that the order of operation is actually working in this exact way. So what we did now, instead of using a context filter, because right now we don't need it anymore, we were not using a top N anymore. So if we go back to a dimension filter, nothing is going to change. My last example related to the query pipeline for today is going to be a more complex one. So I'm going to show you how to leverage level of detail calculations inside your query pipeline. So how many of you have already used level of detail calculation? Raise your hand. OK, so I can see a good majority. So this will be very interesting for you. So for the ones of you who don't know level of detail calculation, I'm going to give you a just one-line explanation. You can use these calculations when you want to compute something that is not related to what you have in the view. So when you want a calculation that is independent from what you have in the view, then you're going to use the fixed calculation. That is the one that we're going to use today. And fixed calculation is going to behave like the top N that we saw before. So this will be applied after context filter and before dimension filter. And just for your information, include and exclude are the other two types of LODs, but we are not going to touch on them today. So let's see an example of how to use an LOD and how this is going to impact our query pipeline. So right now, we're looking at the percentage of page views around the world. We're still with our Pantheon dataset, and we can see that 39% of page views come from the US. But if I want to look, for example, at the UK, where I live, I can see that the 12, almost 13% come from there, and Italy is going to be very difficult to highlight. Yeah, it's a bit more than 4%. But again, this is like very clunky. I have a lot of information here, so I'm going to filter to Europe only. And when I do that, if I go back to my UK page views, they were 12 before, 12%, and now it's almost 30%. So what happened here, and why numbers are changing? Let's have a look at our query pipeline. So the first filter to be applied in this case is the dimension filter. So when we filter down to Europe, then our table calc that we're using after, that is the percent of total. So right now, when I filter down to Europe, the 100% is going to be Europe. And that's why the number is changing. And if I go back to all, the 100% is going to be related to the whole world. But what if I want just results? I want these results to stay the same. I don't want them to change when I filter down to one specific continent. The calculation that we're going to use is the fixed LOD, because we need a calculation that is not going to be affected by the dimension filter that we're going to use on continent. And let's see together how to do it. So when I need to apply calculations, I prefer to use bar charts or tables just to be sure that the result is going to be the correct one. And then I can reuse this calculation in my map. So right now, we are visualizing the sum of page views. And let's think about what is a percent of total. It's just a ratio between this number and the total page views overall in my dataset. How can I compute these page views overall in my dataset in a way that is not going to be affected by the dimension filter? I need an LOD calculation. I'm going to make it big. So in this case, we're going to use fixed. And we're going to fix it to the whole data set. And I'm going to compute sum of page views. Let's close this, and let's call it total page views fixed. When I drag this here, I can see that the total is repeated over and over. That was exactly what I needed. And this number corresponds exactly to the total of page views that I have here. And right now, to compute a percent of total, what I need to do is just to divide this number by this number. And let's do this together. So I'm going to drag my first calculation, sorry, my first measure, divided by the second one. So you can just drag dimensions inside your calc, and the type of aggregation is going to be the same. And let's call it percent of total overall. We need to change the number format to percentage. And when I drag this new percentage, I can see 39% United States, UK is 12%, and now when I filter down to Europe, the number stays the same. Okay, here is the explanation. Why the number stays the same? Because the fixed LOD is happening before my dimension filter. So I'm computing the sum of page views overall in my data set. Then I'm applying the dimension filter, but this one is going to impact just the simple aggregation that I have on the sum of page views per country, but it's not going to change in terms of number. I'm just filtering out some continents that I don't want to see. And this is how I can reach my result, and I can have the number not changing over here. So if right now I drag, right now is correct, I think. I think I had it already in my result. That's fine. So what I should have done was just replace the percent of total here with the new one that we just computed. OK, so this was the last kind of example related to the query pipeline. And before giving you some takeaways, I'm going to give you some examples that are more business-oriented. So we had fun with Pantheon, but let's see together when, for example, we need to compute what are the top 10 best-selling cities across Europe with quantity above 250. So we have seen this already, and let's try to use our knowledge and apply this here. So I already filtered down to the market that is Europe. And right now, we need to filter down to top 10 best-selling cities across Europe with quantity above 250. So in order to do that, I'm going to start by dragging the quantity filter here. And in this case, it's going to matter if I select the first one or the second one. And I need to select it at an aggregated level. So I'm going to select sum, and I'm going to click on Next. And from here, we said we want to focus only on the ones that are bigger than 250. When I do that, I have some results, like a list of results that is lower than before, but still is not they are not just the top 10 best-selling cities, but we have more than that. How can we compute it? Again, if we have a map, I always prefer to go back to a bar chart. And let's make it a bit bigger. So we have seen already how to do this. I can either drag city here and select top 10 best-selling. So we're going to select sales, so by sum of sales. We're ending up just with one result because we were filtering down just to Europe. So what do we need to do? Just add this to context. The other way to compute this will be to use a rank. So in either way, we will get to the same result. The last, now it's the last for sure, business-oriented example that I prepared to you is going to focus on rank. So right now, we need to know who are the top 10 most profitable customers for each segment. So how this exercise is different from before is that we want to have this top 10 for each one of these segments. So if I show this segment filter, we can see that we have 3 segments. So I want to have these 30 results at the end. How I'm going to do that? Right now, I'm going to leverage filter. So I'm going to duplicate this measure here, and I'm going to apply a rank. But when I apply the rank, I can see that the first customer is ranked second, and then third, fourth, and seventh. Why is this happening? This rank has been applied overall in my data set. So if I go to the next segment, I can see that here I can find the first customer overall. But what if I want this rank to be repeated for each one of these segments? I just need to right-click here and use my Edit Table Calculation pane. This is very, very useful when you use table calculation, because from here you can control how the table calculation is computed. And instead of applying it table down, we're going to applying it pane down. So this rank is going to be restarting for each of the segments. And when we do that, we can see that now it's starting from the first one, second, third, etc. And now we can use this as a filter, as we saw before. And as you can see, I have my top 10 for each one of the segments. So when you need to compute a top 10 for different, in this case segment, but for different categories, then a table calculation and controlling it from compute using is going to be the solution. So this was the last example, but before leaving you, I'm going to give you my last key takeaways. So I told you at the beginning of the session that by the end, I wanted you to know how to use the Tableau order of operation to build your visualization, and how to choose the right set of filters and operations. And we have seen that. And we have also seen how to troubleshoot unexpected results after applying some filters. So if you just print the query pipeline, and if you stick to your desk as we do in Tableau, then when something like that happens, then you can leverage the query pipeline to get to the right result. And I told you that it is not important to remember by heart the query pipeline, but if you want to remember just 3 things, I will suggest you to remember these 3 ones. So the first one will be that context filters are independent from anything else that there is in the view. So if you need a filter that is independent, go for the context filter. The second one that is the kind of opposite is the table calc filter. So we've seen also with this last example, if you need something that is computed in the view, then you're going to use the table calculation filter. And the third one is that if you need the calculation to be independent and to be applied before dimension filter, then you can choose the fixed LODs calculation. And overall, just remember that order matters. And also, the most important key takeaway for me today is that now you know how to cook a delicious dish of pasta. And I'm going to give you some related sessions to this one. The first one is happening today. It's a calculation survival guide. And the second one, actually, I'm going to present this second one as well tomorrow. So if you enjoyed this first presentation, and if you want to know more about LODs, I'm going to present this tomorrow. And I'm sure everyone told you this already, but yeah, please rate the session do the survey in the mobile app, because your feedback is very, very important for us. And thank you very much for coming.